Hi and Assalamualaikum. For this video, I would like to talk about postcode modulation assignment for our communication principle from BEEC section 1 group 2. So, our group members, myself is Adwa Aiman Saha bin Azahari, and other group members is Amni Najiha binti Abdul Aziz, Nasha Atira binti Zainal, and lastly Nurul Najiha binti Muhammad Musa. So, objective of this experiment is to understand one of the digital modulation technique. Next is to generate the postcode modulation, or known as PCM signal, by using MATLAB. And lastly, to plot the postcode modulation PCM signal using MATLAB. So, what is postcode modulation? Postcode modulation, or known as PCM, is a method of converting an analog signal into a digital signal. The amplitude of analog signal can take any value over a continuous range, and it can take on an infinite value. And lastly, the difference between the original analog signal and the translated digital signal is called quantizing error.
Starting with example 1, firstly we need to close all and declare the time to 0 to 3 with time interval of 0.01. Next, we declare the A for the sine wave with formula sine 2 pi times t with frequency of 1, and P as the square wave with formula 2 pi times tan times t. Then we are going to set everything below 0 to 0 for square wave, and we are going to generate the sampled signal by getting the value of dot product sine and square wave. Then we are going to plot the graph by declaring the subplot, plot, the label for x and y axis of time and amplitude respectively for both analog and sampled signal. When we run the code, we will get this kind of graph, but since the graph is cut out at the end, I will put time in each plot coding so that when we run the code again, it will look something like this. For the encode and decode, we are going to declare the bits of quantization n to 3 and declare the variable y equals to uniform encode with parameter of s for the input, n for the bits of quantization, and 1. And variable r equals to uniform decode with parameter of y as the input, n is the bits of quantization, and 1. Then we are going to plot the two signals with title of encoded and decoded signal, where the output will look like this. But then again, the time is incorrect, so I will put t in the function plot just like this. And this will be the output. Lastly, to plot the square signal, I will put the time axis so that the output will look much neater with axis of parameter of 0 to 3 for x-axis and negative 0.2 to 1.2 for y-axis. And this will be the output. For example 2, firstly we are going to clear all the variable, then we are going to declare the time 0 to 3 with time interval of 0.01. Variable x equals to sine 2 pi times t is the formula to get the sine wave with frequency of 1. Then we are going to set this variable to the function compend with parameters of x for the sine wave, 255 for the mu value, 1 as the input signal peak magnitude, and mu compressor for the method. Again, we are going to encode and decode using the function uEncode and uDecode for this part with quantization bits of 3. Next, we are going to expand the decoded signal using the function compend, but this time with mu expander method. Then we are going to plot the graph of using compending and without compending, with red indicating the original signal, while black and green indicating the using compending and without compending respectively. We are going to put t in the plot function again to avoid the graph from cutting off at the end, and when we run the code, this will be the output.
So I will explain about the exercise. So the number one is, what is the frequency of the analog signal that has been used in the example 1? So the formula is sine in bracket 2 pi ft equal to sine 2 pi, which is frequency 1 times t, equal to sine 2 pi t. So the frequency is 1 Hz. Number 2, generate a 2 kHz sinusoid with a peak-to-peak voltage of 2 volt plus minus 1 volt. Generate a quantized signal when n equal to 8 and n equal to 16 level. Calculate signal to quantization noise ratio SQNR. So for n equal to 8, SQNR equal to 10 log 3 8 to the power of 2. So the answer will be 22.83 dB. So for n equal to 16, the SQNR is 10 log 3 16 to the power of 2. So the answer will be 28.85 dB. Assalamualaikum and hi. Here I will explain about the Simulink for question 1. So this is the diagram for sample signal and analog signal. In this diagram, we contain signal generator, pulse generator, dot product, and also scope. For the scope, we need to put two number of input because the first one we need to connect to signal generator and the second one connect to the product. So I will show you the output for the diagram. So this is the output for the diagram for sample signal and analog signal. As you can see here, this is the diagram for encoded signal. The difference between the diagram of sample and signal and analog signal, I add a uniform encoder and the number of port for scope is 1. So I will run the diagram and we will see what the output that we get from this diagram. So this is the output for the diagram. So next I will show the diagram for decoded signal. So this is the diagram for decoded signal. So I add the uniform decoder and connect it to the scope. So I will run the scope and we'll see the output for this diagram. So this is the output for the decoded signal. So next one, I will show the diagram for square signal. This is the square signal. So I have added a new scope. This is scope 1 which connect to the pulse generator. So I will run the scope 1 to see the output for this diagram. So this is the output for this diagram, which is the square wave.
I would like to present how to produce the output sine wave for question 2 using Simulink. Firstly, we need to do for 3 bits. The block we use in this Simulink is signal generator, uniform encoder, uniform decoder, and scope. How to find the block in this Simulink is click the library browser and search the block that you want. Okay, firstly, click the signal generator and then set the frequency to 1 and set the unit to Hertz. Then uniform decoder set the bits to 3 and also uniform decoder set the bits to 3 bits. Okay, after that, double click the scope and click run. To get a result without zooming, we need to change a stop time 10 to 3. So this is the result of output sine wave without using compounding of 3 bits. After that, by using compounding, we need add 2 more blocks, which is mu law compressor and mu law expander. So double click the signal generator and set the same. We use the frequency set 1 and unit hertz. And mu law compressor set the mu value to 255 and peak signal magnitude to 1. And for both uniform encoder and uniform decoder, set the bits to 3 bits and set the mu law expander the mu value to 255 and peak signal magnitude to 1. And double click the scope and click run. So this is the result of output sine wave with compounding of 3 bits. Next, we need to do for 8 bits. So in signal generator, we need to change the frequency to 2000 kHz. Uniform encoder and uniform decoder, we need to set the bits to 8 bits. And then double click the run and click run at the top. But before that, to get a result without zooming, we need to change the stop time to, before this we use 3 and now we need to change to 0.001. So this is the result for output for sine wave without using compounding of 8 bits. Next is by using compounding, we also need to add two more blocks, which is MU low compressor and MU low expander. So in signal generator also the same, we use the same frequency, 2000 kHz. MU low also same, the MU value 255 and peak signal magnitude is 1. For uniform encoder and decoder, we use the same bits, which is 8 bits. And MU low expander, set the MU value is 255 and peak signal magnitude is 1. So double click the scope and click run. So this is the result of output sine wave using compounding of 8 bits. Lastly, we need to do for 16 bits. So in signal generator, we still use the same frequency, 2000 kHz. But for uniform encoder and uniform decoder, we need to set the bits to 16 bits. And double click the scope and click run. So this is the output sine wave without using compounding of 16 bits. Next is by using compounding, we also using the same blocks, which is MU low compressor and MU low expander. So in signal generator also we still use the same frequency, which is 2000 kHz. MU low also MU value 255, and for both uniform encoder and uniform decoder, we need to change the bits to 16 bits. So MU low expander, the value of MU is 255. And double click the scope and click run. So this is the output for sine wave using compounding of 16 bits.
So for discussion, for assignment postcode modulation, or known as PCM, digital modulation is the process of encoding a digital information signal into the amplitude, phase, or frequency of the transmitted signal. The encoding process affects the bandwidth of the transmitted signal and its robustness to channel impairments. In general, a modulation technique encodes several bits into one symbol, and the rate of symbol transmission determines the bandwidth of the transmitted signal. Since the signal bandwidth is determined by the symbol weight, having a larger number of bits per symbol generally yields a higher data rate for a given signal bandwidth. On the end of the exercise question, we are asked to do simulating of each question 1 and 2, where simulating is a graphical extension to MATLAB for modeling and simulation of systems. One of the main advantages of simulating is the ability to model a nonlinear system, which a transfer function is unable to do. It also provides an interactive graphical environment for modeling, simulating, and analyzing of dynamic systems. It enables rapid construction of visual prototypes to explore design concept at any level of detail with minimal effort. We also been asked to find the frequency of the analog signal in example 1 and find out how to generate a sinusoid with a peak-to-peak voltage by calculate signal to quantization noise ratio, or SQNR. So for the conclusion, in this assignment postcode modulation, or known as PCM, we learn to understand one of the digital modulation techniques such as postcode modulation. We also being able to understand and generate MATLAB simulating in the question section, and lastly, be able to generate and plot the postcode modulation PCM signal by using MATLAB.